thank you very much. Thanks for having me. Now it's 9 years because I applied a year ago at Adobe. Thanks for joining, everyone. My name is Baubak Gandomi, and I'm going to talk to you about how we test system changes, or how we can test software when system changes happen. There. So I've been working at Adobe for the last 9 years now, and I work at a unit called Adobe Campaign. It's the digital marketing of Adobe, and I work as a test automation architect here. I basically try to help people solve problems about how we can automate problems and how different units at Adobe can do end-to-end testing. One of the problems I've been very interested in, and one of the problems we've had, have been how do we manage upgrade testing? In particular, that has been a big pain at Adobe, or our unit, and I've always been interested in it. So we identified that this goes beyond just simple upgrades. Let me just, there. So the program today is I'm going to tell you about the system changes as we know it.
And what this really tells me, right, is that companies are struggling to understand how to deliver features with quality that delight their customers.
There's a noise. Oh, here. Okay, can you hear me?
It's difficult to hear you in the room. We're trying.
Okay, so I'll try to make it speak closer to what I think is the microphone. So, I'll be talking, this is the program, and I'll be talking about the phase testing as a solution and how this can solve the problems. When we mean system changes, the problems we try to solve are problems such as database changes, upgrading databases or migrating to different types, application upgrades, and server and cloud changes. If we move forward, historically, the way we would try to solve these problems by run our scenarios and simply do the change and make sure that nothing bad happened historically. Another way of doing this was, oops, sorry. Oh, there. Can you see my screen?
Yes. No, we lost the slideshow.
Okay, sorry, I'll go back. And there.
Okay, we can see it again.
Thank you very much. So another way was that we would just perform an upgrade on the system and simply run our tests and hope that they would go well. But there were a lot of problems, and finding bugs was always leading to a lot of frustration for a lot of reasons. One was that it was very hard to distinguish between problems related to the system change and those inherent in the product. It was also very hard to reproduce these. So you would show a problem to someone, they wouldn't be able to try to reproduce it. It was very, very hard. And how do we give this opportunity to developers or anyone to reproduce a problem we've discovered? And there were a lot of issues that we would miss. Also, a system that has already changed, it's very hard to go back and reinitialize. An in-depth analysis of these issues led us to resume the problems in the following cases. So we identified two items. One was the data problem, and the other thing is the time problem. Now let's look at each of these problems one by one. The data problem refers to the data, of course, and the problem is that it's very hard to map data to a specific scenario. Also, when you upgrade a system, the data is lost. It's changed already, so it's biased. Another problem was mapping data to a specific product or application version was also very hard. Data changes, data models change from one version to the other. So it's very hard to also update the test data based on these kinds of systems. Now, let us look at the time problem. The time problem, as we identify it, is that transactions are not atomic. So what do I mean by that? And that is that in a simple scenario, we would be, let's take this standing scenario, which I'm going to use throughout this session, is that a normal scenario would be we search for a product, we put it in our basket, and we pay for it. It's a normal web scenario. And normal tests, or automated tests in particular, would do this as an atomic action of A, B, C, and they don't stop. But the thing is, when we say about atomicity, is that this does not really reflect how people do shopping. People would search for items, they would go and have a coffee, talk to their friends, afterwards they would put it in their basket and probably sleep on it. And afterwards they will say, okay, I'll buy it, and they'll do a checkout. So time goes between these steps. And although it's normal to test these as one atomic action, it's not really what reflects. And what happens is, in between these steps, a system can change. A lot of things can change, data can change. So there are a lot of problems that can happen here. Now, there's another problem with time, and that is that user transactions are not that unique, especially in web systems. We identify that although if we take our same scenario, there are a lot of people doing the same thing, and they're taking their time, they're doing things in non-atomic ways, but at different moments. So people are at different stages in their process or workflow, if we can call it, and the system changes can happen in these times. We tried to solve these issues at Adobe in the beginning by writing scenarios where we would do one step in the scenario, do the upgrade, and then continue the step and see what would happen. Basically, that if our client was in a step of like searching, we would do the search, stop the system, upgrade, and then continue with the scenario. But if we really want to look at the scenario will be expanded in a different way. And that is that if for a three-step scenario, we would have 4 different use cases. And these are all very relevant and pertinent here. And that is that it could be at any part of these steps where the upgrade will happen. So let's move on. And to deal with this, the problem with data and time, we came up with the concept of phase testing. We tried to solve these problems and try to expand the way we would write our tests. For this, we came up with 2 precepts. The first thing is that a normal test scenario should be interruptible. Basically, a scenario should be able to stop at any point and continue where it did. Another precept that we came up with is that a test scenario should only be declared once. We shouldn't duplicate scenarios many times, and that's actually what we did in the beginning. We should declare it only once, but we should be able to expand the scenario so that it is re-executed with all the possible interruptions. And that is what is really phase test is in a nutshell. To move forward, we came up, I'd like to present some nomenclatures before we move on, and these will help for what I'm going to speak about. The first one is the test scenario, is any scenario we know. It's a set of steps, a set of actions that led us to validate a functional use case. And a step is a step in the scenario. We all know this. Now we're going to move to more dedicated nomenclatures which are dedicated to phase tests. And these are the following: phased events, phases, execution modes, shuffle groups, and phase contexts. I'll talk about each and every one of these. The first item is a phased event, and that's what we talked about earlier on. It's really what are the system changes. We call these phase events. And in this particular case, we're talking about interruptive phased events, that the system stops. And we have the notion of phases. We have two phases. One is a producer and one is a consumer. The producer phase is all of the steps that happen before a phase event, before the system change. And the consumer phase is all of the steps of a scenario that are executed after a phase event. So if our phase event happens after we put the item in our basket, the first two steps are in the producer mode, and the last step will be in the consumer mode. So let's move on. We have execution modes, and that is, we have three ways of executing a phase test. One is a non-phase. Basically, it's the same scenario. We just execute it as an atomic action. And that is very good. We need to do this on a usual, regular basis. The same scenario has to allow us to execute things one by one. This is the default mode of execution. The same scenario, when we choose to then, can be executed in another mode, which we call a shuffle run. Basically, a shuffle mode will execute the same scenario with all the possible interruptions that it can be subject to. And we uniquely identify each of these executions as a shuffle group. So before the system change, we perform the scenario end to end. This is a unique execution, so it's uniquely identified. We recognize it as such. So it first executes everything from end to end, then it executes the same scenario, but with two steps only. And then it executes the same scenario with only one. And each of these shuffle groups we perform the system change, and after the system change, the scenarios and the shuffle groups will continue where they left off. So this is really how we do the shuffle run into phase testing. The next item, and this is for very specific cases, what we call a single run, and it is when we have heavy cases, heavy processes where the scenario needs to wait for a big change. And that is what we call single run. But I won't be speaking much about this, but it's for predictable heavy level system changes. And now orchestration, and this is how we put this in place, at least at Adobe in our scenarios, and that is we have a Jenkins server that provisions the system. We run the tests in the producer phase. Then we perform the system change. And then we continue the same test suite in a consumer phase. This is really part of our implementation, but this can be done in different ways, but this is how we've done it. Now, let us talk about how do we manage contexts. Knowing that each scenario can be interrupted at will, we need to manage a cross-step context. Basically, make sure that the data is not lost if there's an interruption. By doing this, we ensure that the data is not lost, and if like when we pay for the product in the last step, it should be able to fetch the data which was stored in the previous steps. This is used using what we call a context API, and we have two steps. Basically, that's why the phases are called producer and consumer. The produce when a step needs to store data for the following steps, it uses a produce. And when a step is reading data to be able to continue, it uses a consume. Let's look at this, what happens in our scenario where we have performed the update. And in this case, we see, in this standing case, we can see that the first step, the search item, stores data in the cache. The second step reads it. Before we go to this major change, we store this in a storage device. It could be a file system or a SFTP server, but that can be configured. And after the scenario is finished, we perform the change, we import the phase data, and then the last step will be able to fetch the data that it needs. Okay, now the implementation and how we implemented it. So all of this until here has been theory, but the way we implemented Adobe was we implemented this as a TestNG listener. I don't know if a lot of people know it, but this is how we use it. And it was basically because our tests were already written in TestNG, but we think that this can be written in anything else, so it doesn't have to be TestNG. And writing a phase test, this is one of the particularities, and that it is part of why one of the problems with Java and TestNG is, in our case, one scenario is one class, and one step is one method. And all steps, at least they need a string argument, but that's how TestNG is. And we need a predictable order of steps. We need to be able to make sure that step one happens before step two. In TestNG, this is done with an alphabetical order, fortunately. And we discovered while implementing this that this saved a lot of space because we didn't have to have redundant scenarios. Historically, we would rewrite the same scenarios, they would stop manually, and then they will continue. Here, it's the same scenario that we execute as shuffled mode or as a normal mode. We had to make sure that we do not write, how should I say, have too many steps, because that could lead to some complexity. But we managed to reach around 5 or 6 steps. And we need to also introduce randomness, because the scenarios are the same and the shuffle groups are very similar, but they need to be unique data. Otherwise, there will be problems with the data. Okay, I'll move on to the demo. And let me just over. Can everybody see my screen? Yeah. Okay, so this is, as you see, this is the code for a test. It's the shopping basket, so I've really used this. The first step is we search for a product. The next one is we add it to the shopping basket. And the last step is we pay for the product. Now let's try to run this. Okay, can everybody see my console?
Yes, we can see it.
Thank you. So here, let's just run the test. Here I'm running the same test that we just saw. And it's just a simple end-to-end test. It just runs all 3 steps in one go. Now, what I'm going to do is I'm going to simulate our system as it is in the Jenkins. I'm going to provision this system. And what I'm going to do is I'm going to first execute it as in a producer mode. And then I'll execute it in a consumer mode. if we look at the results, excuse me. Sorry. We see we've run three scenarios. So now let us try to make this a bit different. I'm going to redo this. I'm going to write it, do the producer phase, and then I'm going to manually perform an update that causes problems. So here, in the test scenario, I'm actually checking that the prices haven't changed, but I'm going to perform an upgrade where I'm changing the prices. In the test scenario, I'm actually checking, when I pay for the product, I make sure that the price that I paid hasn't changed. But here I've actually performed an update where I do change the prices. So now if I perform the consumer test, the test will fail because there have been changes in the system that were unwanted. So the test will fail here. And if we look at the same scenario again, we'll see that the expected price has changed. So here we've managed to see that the upgrade test failed, but in one particular case. It's just when the change happened before for when we put the item in our basket and the change happens after. Okay. So let's go. I'm reaching the end of the presentation, so I'm going to talk about the conclusions. So basically, the takeaways I would like you to leave this meeting with are we would like you to think of scenarios that are no longer atomic. We do this normally in our automated tests, but phase tests look at scenarios differently and saying that they can be interrupted, and they should be. And system changes can happen in the lifetime of a scenario or a workflow. We also think that it's important, basically, phase tests allows us to make sure that people can continue what they were doing before the system change. There are a few considerations that need to be thought of. We're not saying that you should change all your tests. At Adobe Campaign, what we saw was the best candidates for phase tests were the sanity tests and smoke tests. So if our normal sanity tests would, if we transformed them into phase tests, they could work as normal sanity tests on a day-to-day basis. And whenever we have a new version of the product, they allow us to test the new product version. So these are really the considerations that we found were helpful. And it's not good to have too many steps. If you want, you could, but you will get a lot of phase groups. Now, this is a work in progress, and it's far from being perfect. It does help us a lot, but we're seeing that there are other domains where this can lead to. Sorry. So one of the items we discovered we can do with phase tests is that we're able to deduce the order of the steps. And this will be something I'd like to work on. It's identifying that if we see that two steps can be interchanged, then we should be able to run the same scenario with the different order. This is technically possible, and we would like to go there. Another item we've seen that I'm thinking of, and I'm happy if anybody would like to contribute, is non-interruptive events. In this, what I showed here is mostly interruptive events where the whole system stops and we perform the upgrade. But there are events which are not upgrades or major system events, things like you would fill the database with a lot of data. Or in my demo, I actually changed the price while we were doing the workflow, right? So that is a non-interruptive event. So that would be something it would be interesting to work on, that we don't have to stop the system. Another item we think, which I'm very excited about, are parallel events, things that happen not between steps, but during a step. That would consist of chaos testing, actually. And we think that in the implementation we've done with phase testing, we should be able to implement parallel events and also do chaos testing of our scenarios. Again, we also like to work on multiple events. But there, who knows, there are a lot of other domains of testing, and I'd be happy to see if anybody has other ideas. We think this is very exciting, and we'd love to see ideas or suggestions, so feel free. You can access what I've presented here in, so the code is public domain. It's within the Adobe organization of GitHub, but you can access it in phase testing. You'll find the link to it in the article as well. The demo is on my personal space on GitHub as well. I've documented how you can execute it and what it looks like. It has a little bit more details in the README. You can play around with it. So thank you very much. Sorry for the microphone problem. I really appreciate you joining, and I find it very exciting to have such colleagues in this domain with me. So any questions?
Thank you very much, Baubak. We got the audio sorted out a little better in the room. So, well, we have about 15 minutes. If anyone in the room has questions, just raise your hand. I'll bring the microphone over to you. Or if anyone online, you want to put it in the chat and I can read it out. Floating over, so hopefully everyone can hear you.
Okay.
It's just a brief question, but on the slides, it was a little hard to see the GitHub repository. Is there a way that we could potentially get that so that we could check it out after the conference?
Absolutely. It's in the article, but I can put it here while we're speaking. Let me just see how does this work. Can I chat to everyone? Wait a second.
Yeah, it's in the room. It's hard to see on the screen, but you said it's in the paper online.
Oh, yeah. It is on the paper online. That is true. I'll just put here. I have it here, and
Could you read out the link as well?
okay. It is github.com, Adobe phase testing.
Be able to see it in the chat as well that I have up.
Yeah, I put it. I just put it there. Also put the demo. So I'm very involved at Adobe with public open sourcing and projects like that. So we're very excited about this. Again, this is our unit that is testing this. This is not, I'd like to highlight that this is not used by everyone at Adobe because we're quite big. But this has helped us a lot. So we're very, we find it very useful. Any other questions?
So there's a couple in chats. So from Henry Lee, what is the max number of steps you've created for this kind of test?
8 so far. The basically, yeah, it has been 8, really. The problem with 8 steps is you have to realize that if we have 8 steps, we will have 9 phase groups. So you'll actually end up with a lot of tests. And I like that. I find that very exciting to have a lot of tests that sort of like generate more tests. But it gets hard to read, to be honest. So we were looking, that's also a domain we need to get better at, to how to resume the, how to make it clear for people what the test results are. I have a question from Angelo Contgas. There is no book. I'd love to write a book, but it would be, I've written an article in the domain of this seminar, so that's available. And you can read it, but I haven't planned on doing the book. Who knows? I have a question from Henry Lee. If I have a fairly long workflow, do you have any advice, suggestions on how to slice up or partition our steps? Yes, actually, there's nothing wrong with merging the steps. So what will happen is that there are sometimes steps that can be put together. I'll give you an example. Let's expand our scenario that we have, right? The web shop. So imagine we have additional steps. I've made it very simple here, right? So the user logs in and they search for a product, and then they search for a second product. Let's put it that way. For example, in the checkout, which is very simplified as well, they perform a checkout and then they pay. So we can look at that we merge the steps into the same. So we can, so instead of saying checkout and pay, we just do the user pays. So it's really up to you. It's really how you group your steps. You can have a lot of steps again, but you'll have more data to check. It's really that. Okay, any other questions? I hope I answered your question properly, Henry and Angelo.
You're good, thanks.
Thank you. Any other questions?
Well, I'll ask one kind of pertaining to what
Sure.
I'm currently doing for work. With any of these steps, have you interrupted them with a time? So to say, well, we're going to do this step, then we're going to wait 5 minutes before we continue.
You know, that is a very good question. I have not. However, in my unit test of the single, how should I say, the single phase, I do that. I would call that will be in the next step. I would, because it's not what I call an interruptive, how should I say, interruptive event. It would be a non-interruptive event. And that's actually what I'm working on right now to try to get this working. But yeah, I mean, it could be anything. It's, we created it for software updates because they do cause a lot of problems. But we're thinking that there could be a lot of things, you know, like spending time between the steps, integrating random sleep between each step. So these are things that we can do in theory, but it's not in the product right now. Let's put it that way. But it's definitely in the scope.
Do you have any more questions in the room?
Okay. Well, if you have any questions, please feel free. You could always contact me on GitHub, or you can contact me on my normal email, which is at gandomi@adobe.com. Feel free to contact me again. If it's regarding phase testing, you could always also drop a line there, or contact me any way you like. I'd be happy to answer you. The thing is, one of the reasons I'm doing this is to really get feedback, have such good questions as what you've asked, because these are really useful. I've been getting very good feedback from the proofreaders as well. So this just makes the work better. So there is no perfect solution to things. It's just how well it's used and how well it's challenged, really. So thank you very much. Thanks for listening. And I wish you a great time.